Hi everybody, welcome back today. I am Sam from Python Basics, and we'll be doing another 2-hour live stream today on freeCodeCamp here. And the way the agenda usually works is it's about 2 hours. Don't see anything happening today. Was not feeling too hot last week, but we are going to finish up some dictionary stuff because that was requested, and that is very, very important to me. And then I think there were a couple, we were talking about formatting, and maybe we'll look just real quick at formatting some numbers, and then we're going to jump into scope. And the reason why I like scope so much is really lays out how Python looks at variables, and scope is just basically layer of priority of where it's pulling from. So and then we'll look at nested functions, and then those are just a half a step, a half measure that gets us to decorators. And if we have time, very cool use of nested functions. And it'll take us a while to get to some really case scenarios of decorators, but I will show you how they use. But the one today, if we get to, and I'm super excited about it, is the Monty Hall example. So, all right, let's just get into it. Is everybody here? Everybody ready? Yes, and I had completely forgotten this. So I had gotten some feedback that maybe there was glare, and I know I've seen this a lot of times that people like the darker. So what does everybody think about the dark background? Is it easier to see? Because the red is a little hard. All right, let's go. Cool. We're glad to have everybody here. So let's just get into it. So let's finish up dictionaries so we can get on to our new stuff. All right, so what I really want to look at to wrap up dictionaries is the reason why they're very powerful. Is one of the awesome examples is if we were to make a link and a basically a building block of association. So let's just look at the alphabet real fast and then tie these in. So we don't need this. Let's comment this out. But also, one thing, a little crash course reminder about the dictionary. First, you have to initialize it, and then link a value to the key. All right, don't need this anymore. But I hope everybody has had a good week. I am glad to be back. So from string, import as key, lowercase as lower. So, all right. If you are unaware of this module, built-in module, and basically what we're doing here is we're building, it's one of the ones that I like to do for a really encryption and decryption, pretty cool building block of messages. But for I in range len lower than key. All right, so what I'm doing is I'm going through this. The reason why I'm using the range len function is so I'm going through, so I don't have to go and wrap an enumerate object, wrap it up, so I can just go through here. And then we're going to look at counting with a, all right, then run this, then called key. So, oops, that is not what I wanted to do. What did I leave out? There we go. Key. So for I in key, print. So what I did is I associated, actually for items, print, and I need key value, key, comma value. So what I did is I went through our built-in lower, all the letters, So lower, just so you can see where I got this from. If you're new joining us, does anything here not make a lot of sense? All right. Awesome. I'm glad you guys are liking the background. Hey, is it very blurry on your playback? Because it is very blurry on mine. If you guys are seeing it good. All my kids are home. I was kind of a little worried about this today. Is the picture clear for you guys? If it is, that's great. Because like I said, all my kids are here and we're all streaming. Awesome. I'm glad the darker is good. All right. Okay. Not hearing any feedback that it's bad, so I'm going to keep going. I don't need to see me. I'm just looking over here at the chat. Okay. So I took and I ran through. Okay. All right. Okay. So what I did is I ran through and I made a dictionary and I associated a key. So you could flip this around. So basically you could, the reason why I like this exercise is it gets you to understand to go through, because you'll see in a minute what we're going to do is we're going to count. We're going to count if it's in the dictionary, we're going to increment up. If it's not in the dictionary, we need to create it. So we're actually going to look at The Raven and the poem The Raven from Edgar Allan Poe, and we're actually going to count all the letters. All of the words in the poem. That's what we're getting to. So all right, I went through, I took the letter, then I associated a number to it, and then incremented up each letter. Or I let Lynn, the range, increment each one. So I went through and I went through each letter, then went through range. So range iterated through my lower, and then I let that count and I let that be offset by 1 because we know range starts at 0. Now I'm going to show you how to do this where we can zip the dictionary. And this is where it's very cool. And if time allows, I'll show you how to do dictionary comprehension. All right, so we don't need this. We comment that out. And we can do this in 3 lines right here. So I'm going to do this a little stretched out so we could see this. I could do this in 2, but just so we can, letters equals lower. So just so we can have this together. Then num list range 1 through 27. So we're offsetting 26 letters. All right. Then key, wrapping this. So we're making a zip object. So check this out. This is so cool. All right. So thing about a zipper. So you have the actual zipper, then the 2 sides, and it goes through and it overlaps. I don't even know if I'm in frame here. So all right, it goes through and it zips each side together. So I have 2 objects that are the same length, and I zip them together. Then I'm telling it to turn it into a dictionary. So I commented all this out. Boom. Oop. Letters. And I'm not spelling anything right today. Sorry, everybody. And then key. Boom. Same thing. So I just wanted to show you how you can create a dictionary with a zip object. Zipping a dictionary. There you go. All right. So cool. We are almost wrapped up. Cool. We're doing this in about 10 minutes. All right. Oh. Is it sporadic for everybody? Is it breaking up? Because like I was saying, that I was a little worried about the stream with everybody on at my house. Quincy or Bo, are you guys available to give me some feedback? Is it too bad and too choppy? Because my view is just completely frozen. All right, is it frozen for everybody? Okay, I just got a yellow and an orange on my stream. I'm clicking over, it's bouncing from red. Huh. I'm not getting any response from anybody. Okay, well, I'm just going to keep going, and we'll go from there until I hear otherwise. So, all right, now we're going to do something pretty cool. So I'm just going to put this in, and I actually have the file. You can go out and pull it down, the Raven, but I also have it on my GitHub, so you can click over to my channel and look at that. But here's the Raven. Here's the Raven. And I'm just going to put it right here. So boom. Here's the Raven, the file. Oh, don't need to comment that out. Now, this is how you go about creating something, and you don't know, like I alluded to or made a passing comment about, a dictionary is very powerful. One of the tools that I like using it for is if I have no idea blurry. Okay, it's going blurry and then okay, it's going blurry and then not blurry. Okay, well, thank you for the feedback. All right, so a dictionary is perfect. So you initialize it, and then if you have a scenario, which you'll run into, and I've had plenty, where you don't know how many variables you're going to have, so instead of thinking of it, you have a key be your unknown. You have an unknown amount of keys. So if it's not in there, and I'll show you exactly how to do it, if that key doesn't exist, you create a new key for it, and then if it does exist, you increment up. And this is a perfect example. So, all right, let's look at this, and it's literally this simple. So we take our file, we're going to then split it. So file dot split. So what does that do? Takes my string, puts it into a list with each. It's going to, I'm not passing it any delimiter, so it's going to split on the white space. Boom, step one. Then I'm going to initiate my dictionary. We're just going to call this book. Helps if you actually then create a dictionary. And dictionaries live inside curly brackets. All right. Then we'll just stick with word in file. Then if word not, however you want to think about this, but we're going to look at it. If it's not in the dictionary already, we're going to create it. We're going to assign it to a count of 1. If word not in book, then book, then our key, so it's word. That's our key, equals 1. Else, then book, word, plus equals 1. So what I'm doing here, taking this file, because it was file variable, then I'm splitting it, turning it into a list. Then I initiate my dictionary, iterate through my list, looking at each word. If that word is not in the dictionary, assign it, count it 1. Then, if it is in the dictionary, then increment that value up by 1. So let's run this. And we have book. Holy moly, 114 lines. This is what I think is so cool. So here we go. So this is every word counted in the poem. Giving open a minute. Making the code shorter. If would you mind giving open a minute in this? Actually what I was planning on doing was we were going to do not just open, but next week we were going to, because I wanted to entice everybody, we were going to then go and actually pull this down off the internet with URL lib and tie URL lib and open together. So that's what I was thinking. I didn't want to deviate too much because I think we already got, but it's a great idea, and you can already, I like how you think, and that's why I think we work well together, is that I'm going to tie those into next week's lesson, so we can, yeah. I'm trying to do a little bit more foreshadowing, but yeah, if we could just stay with this right now, I want to, because open can be a little tricky, so I always try to tie that with something else. So the open URL, well, awesome, good. And there's also, if there's ever anything that you guys want. Because the reason why we're doing dictionaries right now is somebody hit me up on Twitter. So look, this is y'all's tutorial. So whatever you guys want, and if I haven't done the complete lesson plan, I'm more than happy to augment and do what you guys need and want to see. Because I mean, I could talk about any of this, and as you can tell, I can get sucked into some of it a little bit too deep. So. But that's a great idea, and that's actually where we were going to go next week. I didn't want to tie these in and deviate too much, especially with Bo being awesome and allowing me to almost do anything. So just wanted to do, I thought that would wrap up the dictionary, and we might do sorted. I just remembered we didn't do sort here, and don't have my notes right now. But yes, we will do that definitely next week then, because I was on the fence about it. So that solves it. So thank you guys. All right. So where are we? Two more questions that came up last week, and then we'll get into this. So we don't need this. So it was formatting. We were formatting the our probability, the odds of winning Powerball. And I can't remember who asked, but it was, hey, what happens if we wanted to change the format of our number? So what happens if we wanted to do, so here, let's just look at it. And we do phone number, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So basically, it would be you'd hardwire it in because when I did the placeholder colon comma, Python already knows in that string format, in that formatting logic, that it goes and puts that comma after every third. So that was for phone number. That was the example that I had for that. So then literally, if you look right here, I have my placeholder with my string, and then I've wrapped parentheses. So in the United States, we typically put parentheses around our area code. Then our prefix then is separated by the local selection. So it's basically routed to where in the United States, where inside that where in the United States, and then that number. So now let's look at the other one, which is basically the exact same. But it was my example for here in the United States, and I learned something cool about Australia. Somebody was asking how to do the math, so maybe you guys can confirm. But in Australia, if I understood, that is the sequence of when you were born. In the United States, our identification number, our social security number, is built upon geographic. So the first one is what state, then you have the group number, and then the sequence in which you apply for it. So, and this is more dashes, but I just changed it up. So let's see. SSN 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I just go from there. But that was, I just wanted to throw that out because somebody made a comment and you just would need to hardwire it in. So, all right, I think that's that. So very cool. That only took 21 minutes to clean up those things. And I think there's another dictionary, something. Was it? Or did I get it all? One more. Dictionary comprehension. Let's just get it out of the way. So, all right. We'll look at this and I'll throw it in here and I promise we'll be done. So, this is what's cool about this. So, let's look at this. So, all right. Who doesn't like list comprehension? I can't remember. All right. So, basically, same idea. Here's my for loop. So then, now here's my key and value pair. All right. So I have a list of names, an iterable. So I'm going to, here's my iterable. Here's my temporary iter, right? No, I shouldn't have said that. Temporary object, iter is something else. So forget I said that. Here's my loop. Then here's my key and value pair. So what I'm doing is I'm saying I want you to count a student I thought it was him. So, but you just have to look, all right. You just have to do something over and over again. When you got on a bike, you couldn't ride it, right? So I remember when I started doing this and I couldn't understand for loops. Well, guess what? Now I understand them really, really, really well. It's just time and energy. And it really doesn't have to do anything with how long, like how quick you can learn it in 10 years or 5 years or 2 years. Well, it's a length of time. I like to say it's 10,000 hours. You want to become an expert at something, you got to spend 10,000 hours. And that's it. That's it. That's the magic number. If you stretch it over 10 years, okay, it takes you 10 years. If you can compress it down to 5, great, it takes you 5 years. You want to become an expert at something, you got to spend 10,000 hours on it. That's that. So what the standard math is, it's like 6.7 years if you do whatever task for 40 hours a week. That's the math. So let's just look at this one more time. Here's my key. I'm taking my student, the first letter, then I'm putting an upper method on it, and then my value or my temporary. So what I'm doing is I'm saying how many students have this first letter. So I have Steve, I have a John, I have an Adam, and I have a Will. So that's that. All right, cool. You weren't stitching. That's funny. That's very funny. All right, let's get done with that. Let's close that out. I don't need that to run. Don't need to see that and distract me. But I really hope everybody had a good week. Last week was hectic and busy for me. Hope everybody did good. So, all right. So we need to talk about scope. So you're going to hear me use another term, and then so it's local. It's L-E-G-B, and it goes in the reverse order you think it will go. So, and I got a pretty good example that I think that'll really help sell it. It looks locally, so inside. Then it looks enclosing, non-local. So if it's a nested, right outside there, that takes next priority. Then global, then built in. So LEGB. and I'm gonna have we're gonna go through this really slow. So first, I'm gonna handle local, global, and built-in, and then we're gonna do enclosed and closing, non-local. Those are all the same. We're gonna do that next to really kind of wrap our head around it, and I think we will have time to do our Monty Hall problem. So I'm very excited. All right. So I have, well, one. Let's do this so you guys can see. From math import pi. Not super important, but does everybody know what pi is? The mathematical term, the ratio between circumference and radius. Everybody, anybody? That's a old movie from my time period. Not Ben Stiller, but Ferris Bueller's Day Off. All right. Okay, good. So, as you can see here, I have this variable in 3 separate locations, and we are talking about, right now, we're talking about local, global, and built-in. Local, global, built-in. So I'm going to leave all 3 of these here, and I'm going to show you. So it takes priority from local first, global next, well, actually non-local next, but I don't want to, we're going to do that in a minute, and I'll show you. So we'll put this in parentheses. It's not here. Global, and then built-in. And as you can see, I have these at different lengths. So you can see the scientific notation. Wow. I cannot think of that term. I thought I was going to be super nerdy. So, all right, I have all 3 of them sitting here, but Python will look here first because this is local. Then if I comment this out, then it will look global. Significant figures, that's what I'm looking for. So I have, because pi, built-in pi is, I think it's 12. Then my local was 5. Then my global was 2. Then my built-in is 12. So I comment that out. Then it will look, then it looked right here. So then when I comment this out and I run this again, then it goes, then it looks globally. Then it will see that. So the reason why I like doing it in this order is it shows you where it assigns and goes with priority of how it looks. So, all right. Now let's look at a nested function. Now, the nested function is the built-in, is the building blocks of decorators. So this is going to look weird and seem weird. Why would we do this? Well, it's a kind of precursor and a building block for something else. All right, let's comment that. And then we'll use this as a jumping off point to look at our non-local scope. And in several weeks when we build a T-Kenter calculator, you'll really wrap your head around local, or excuse. Oops. Okay, am I back? Am I back yet? I just saw that OBS went down. Everybody back up? Okay. So yes, locals are within a function, global variables are outside and get pulled in, and built-ins are already there. Okay, awesome. Yeah, I apologize, guys, with all this, with everything going on with school. Our kids are delayed going back, and they are all home with me on Zoom meetings. So we are eating up bandwidth like crazy. So hopefully this will all be resolved very quickly. Let me see what color I am. It's red right now, but I think I'm back. I haven't gotten a message. Okay, I'm back. All right. So, boom. then def num, then return exponent in, then return num. So what in the world is going on here? Let's see what color we are. We're yellow, orange, hanging around red. Yuck. All right, it bounced green. Okay. Now it's blurry. God. All right. I will go slow. I need to wonder if I need to send my kids to my parents' house during Tuesdays. We'll figure that out. All right, we'll just go slow today. All right. So, well, that's very cool. Thank you for the new supporter. All right. Just refresh the page. All right. All right. So what are we doing? Let's look at this. So here's our standard function that we're used to seeing. We have, and we are going to return this. Now, this is where it gets weird. This function is going to return this function. All right. So this function, my exponent, my exp function is going to return my num function. So let me give you an example of what in the world this will do. Square equals xp2. So you start on the outside, build your way in. So now this is this. This is where it gets a little weird, but once you start thinking about it, you'll get used to it. So I want to create a function that's going to square something. And this exponent is here. So whatever exponent I pass in, this will be, and then now this, basically, this is how I want you to think about it. Basically just renamed this right here. So function, this renamed this. So whatever I pass in here at the end of this object will take that number and raise this number to the exponent of this. That's why I called it squaring. So now I'm going to put this in memory. Then I'm going to call square. Oops. Square, and I want to square 2. So I get 4. All right. So now I want to make a cube function. Cube. And I go my exp function, and I want to pass in 3. All right. So put that into memory. So then I want to cube. What do I want to do? 3? That's 27. 3 times 3 times 3. 27. Haha, I remember math. Okay. Now let's look at non-local. This is a perfect way to look at non-local right here. So that was our nested function. Okay, non-local scope. All right. So now what happens if I were to pass in a 1 right here? And if I wanted to be able to touch it from this function. Because if I say global, it's going to look outside. So there has to be a way for I just want to move a variable from just outside, not crazy, not globally. It goes right here. So this is how I change the scope of this. I pull this in, say non-local, and now so when I pass in this, so what, I change this up. Whoa, square 3 stays the same because I overrode this and changed it to 1. So I changed it bend. So whenever, and you'll see this when we do our, I think we're going to have plenty of time to do our Monty Hall stuff. Yes. And that is a very, very cool. Yes. Very good. I'm sorry. Yes, the enclosed. So you have non-local. Enclosing, you're going to hear that term. So if you're reading enclosing, that's typically the documentation. Enclosing, I then also call it, so if you heard me say enclosed or non-local. All right. If I used any of those are all the same. This is the technical definition used case enclosing, because it is enclosed. It's not local. It's not global. It's enclosing. So there we go. Great question. This is why I love the interaction, because you guys keep me on task. All right. So now let's look at decorators. So we need to look at decorators. They're very, 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 very cool. They're a little odd at first, and especially they are in these couple of cases, they're going to be weird. You're going to say why, but it's to see the context. Perfect example that I've used is to change a function, especially with Django. So if whenever you're having pages and you're building them, you're building a function for each page, and then you need to lay on top of it some functionality, and you can lay as many decorators on as you want to. Think about it as, because you're going to see it here, and we'll talk about it. A wrapper function. So it's going to take a function, wrap it in another function, wrapping it around. Your decorative wrapping. You're wrapping up the outside. So that's the way I like to describe the decorators. All right. So let's undo this so I can see. All right. So decorator, same type concept here. Just the way that we use it, a little weird. All right. So, did I need to leave that? No, we'll just start over. All right. Decorators. So we're going to take a cube. Then, all right, let's see if we're blurry. We good? All right. So we take, this decorator takes in a function because it's going to sit on top of the function, and you'll see this. So then I just like to keep this wrapper function. So then we take in an argument so we can be really clear so we don't have to think about it. So then we're going to return the function and the argument. Okay, func. And we're going to go real slow because this can be really weird. And then we return the wrapper, right? So this is this and this. Then this returns this. All right, let's look at it. So now I'm going to do a def num x, then return x. Num, pass in 3. All right, so let's go through now. My decorator, it's going to take a function, wrap it up, take that argument, then do this to it. Take this function, take its argument, and do this. So when I do this right here, this is all that it takes. So I don't have to create and go out like we did with our outer, where I'm building my way out to in. This just sits on top, and you still only interact with the function that you're changing, you're augmenting, you're decorating, you're wrapping it up. All right. Does that throw anybody for a big loop? Because I remember the first time I saw this, I said, what? But I'm decorating, I'm augmenting this to the power of 3. All right, now here's one that can be a little bit easier to wrap your head around. That works pretty well. Let's see. All right, you got it's going to be for a string. Upper. So we take in our function, close that out. Then we do our wrapper. Sorry guys, I think somebody's coming home. So this is not going to take any arguments right here. So then it's just going to return the function. Then we're going to have this right here, wrapper. Just like so, just like before. So we're taking our function, which is going to be a string, because this is just returning. And if this is a string, we know that that method works completely. So let's create a def of hi. Then return hi. How are you? Close that out, close that out. So we call hi. Did I call it hi? I think I did. Yeah, hi, how are you? So now, on top of this, I'm just going to slap my upper. Oops. And you decorate it with the @ symbol. Upper. And that's it. Now, later, if we're still working together and we get around to, I don't know, I think they already have a bunch of Django, but that is a perfect one. And those are even more sophisticated, those decorators, because it is a three layered here to take in an argument here to then redirect. But all right, I digress, sorry. Because I know right here that this can look a little odd. You're like, well, why would I? And I get it. It's a great question, because I asked the same one. Why would you need to do this? Why wouldn't you just change it in here? If you have a bunch of functions and you're going through and you only want to then augment specific functions, and you're like, okay, here I want this one to do this, and I want to do this here. So then we just now that we have this called, I got hi and everything's uppercase. Or if you need to call one, sometimes you can have it call another one. But this just sits up, and you can have these layered. I can put more decorators. I can put as many decorators on this as I want. That would work with the type of object that it is. All right. So there we go. That is decorators. Well, awesome. This has gone very quickly. So we have a very long time to work on a perfect example of scope variables and the Monty Hall example. So let's go ahead and get after it. So to give you guys a little bit of a backstory of what the Monty Hall, it was a game show in the 60s, I think, and it was a very interesting concept. So I had heard about it, but when one of my kids was in seventh or eighth grade, they were doing probability and statistics, probabilities, and ran across this problem. So it's, if you have 3 doors, you pick one of the 3 doors, then, so there's a car behind one of those 3 doors. Excuse me. There's a car behind one of the 3 doors. And where the trick comes in is the host of the show will show you a door that is not a winner. And apparently they would have, so there'd be a goat behind two of the doors and a car behind the third one. So what the trick would be is he would show you one of the doors that had a goat, and he would open it up. And what that does to our brains is it messes with the probability. And you then have the option is, do you want to, now that you know which one is not the car, do you want to change, or do you want to keep the door that you have? And almost always the person sticks with their door. And here's the problem. And this was a perfect Python problem for me to come in and do for the class, because we ran a simulation and we did this and we're able to prove this on a huge scale. But if you change doors, you have a 66% chance of winning. If you stick with the same door, you only have a 33% chance. And I was blown away by it. And everybody right now, and I've actually had people leave comments in the video, because I have this on my channel, the original time I did it, and people argue about it because it is contradictory to what we think. And that's why the game show host did it, because most people didn't change doors. So when they change doors, they are 66% more likely to win. All right, so let's get into it. And it's a perfect example. Because I remember when I was first learning, I go, okay. And I did this with some really, really clunky programming. And then I ran across nested functions and scope, and then so I redid it. So I don't think I've redone it. You'll see the original junky version if you go back to my channel. But we're going to have it here. So we're going to go ahead and knock it out. So we're dealing with randomness, right? And then we're also going to be moving the doors around. So we need to import a couple of things from the random library. All right. So from random, import shuffle and choice. All right. So we need to bring this in and look and see what in the world we're doing. So help on shuffle. All right. Shuffle a list in place. What does this mean? Anybody? We've been going over this a couple times. In place, return none. Means you would need to make a copy. If you want to keep the original, you need to make a copy of it. Ooh, that's actually one thing we need to talk about at a later class. I need to make a note of that. Copy. Yeah, hang on. Copy and pointer. Hang on. Pointer and copy. Because we need to talk about this, because you can get hung up on referring to a place in memory or an exact copy. It can be very tricky. All right. Anybody? All right, cool. All right. So shuffle moves everything around in place, will not be creating a new object. And then choice. We need to look at choice. Oops. Help. So what does this do? Choose a random element from a non-empty sequence. So basically we're going to have a list of two goats and a car. And we're going to shuffle it. Then we're going to randomly just pick an index. So our index is going to be our door numbers. So that was the example. They brought out a wall, and it had doors on it. 1, 2, 3. Well, we have a list. Indexing 0, 1, 2, and we're going to randomly shuffle the goats and the car in there. Then we're going to randomly pick one. Then we're going to have the goat from the list from the remainder get kicked out, and then we're either going to keep the one we have or swap for what's left in the list. So it's a great. When I heard it brought up, if I could program something and teach the class, it is a awesome programming challenge. So we have to really be paying attention. So in the nested way we need to do this, we need to create our game, right? So our overall function, and then inside the function, our two nested is switch and what do I call it? No switch and switch. So in a scenario, we're gonna switch 10,000 times. Well, the game is gonna take in the number. Sorry, and then we're not gonna switch, and we're gonna see. And it was very, very eye-opening when I saw this, because everybody thinks. And then I finally went and started looking and was doing some research, and it just shows why this show was wildly successful and why so many people did not win, because it's contradictory to what our brains think, where you're like, well, you just remove one of the doors and I'm going to stick with my door. Well, you just found out that a third of the possibilities have been removed. You need to change doors and you're more likely to win. You're actually twice as more likely to win. All right. Okay. So we need to deal with lots of stuff. Game. Then number of times we're going to test this, and then we're going to change if we're going to change. So we're going to default this to false. All right. So now we have our doors, right? I know I'm saying a lot right now. Any questions right now? Any questions at all? All right, cool. Let's get going. And I think my kids are coming off their Zoom meeting, so hopefully it won't be blurry and it'll stay good. All right. So we got one goat, two goat, car. Close this out. All right. So now we need to shuffle the doors, because we want this to be random. So then we're going to go, how are we going to do this? Anybody got any guesses? I gotcha. Okay. All right. So shuffle is in place. So I want to shuffle these doors. So I don't have to do any assignment right here. So, and let's see. Pass in, take shuffle. Pass in our object. So shuffle. And we pass in doors. So print here. Actually, we already have all this, so shuffle doors. Print, yeah, we'll just do print doors here. So game right now false. Okay. All right. So now it's shuffled, and it's car, goat, goat, and then we run this again. Goat, goat, car. Let's move this over so we don't keep getting ate up. So we got car, goat, 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 car, go, goat, goat, car, goat. All right. Okay. Now, oh, and we need to track. We don't need that anymore. Now we need to track our wins, losses. 0, 0. Now what we need to do, get that down there. Now we need to create our nested functions. This is where it gets fun. All right, cool. So our nested functions, first one is going to be no switch. So right here. So then it needs to know the reason why I'm setting it up like this is, well, one, it's great practice for to wrap our head around nested then non-local, and especially since we have two scenarios inside the game, right? Okay. You can either switch or not switch. Absolutely perfect. All right, and then things will act differently. So no switch. We don't need it to do anything, but we have variables that we're going to be working with, right? Non-local wins, losses, because we want to pull these in here and manipulate them if we pick the goat, or if we pick the car. Okay, and it's literally, now when we get down into the actual game, this is where it gets fun. So no switch is we're gonna pick a door. If the choice is the car, you straight up win. If you don't, but the fun part to laying out this logic is for the switch. So if car equals choice, so let's look at choice again. Choice is sequence, and then so sequence is our iterable, our list. Choose a random element from the non-empty list. So we're going to pass in choice, pass in doors. All right, and oops, then wins. If this choice is car, equal to car, then we're going to increment up 1. Else, losses, because if it's not, oops, 1. All right. Now here comes the fun part, because we really got to do some thinking here. Ooh, we're way ahead of schedule. Okay, I thought all these others would take a little bit longer. All right. Switching doors. Def, switch. Helps if you spell switch, right? All right, let me check my notes. So now we have our doors. Goat, and car. Then non-local, because we're bringing in our wins, losses. Now, all right. So we need to. This is going to get a little complicated. So we're going to pick a door. Then we're going to get shown a goat. Doesn't matter what door it's behind. Then in this one, we're going to grab what's left. So let's think about this for a minute. All right. I need a graphical example. I think I have paint somewhere. All right. So here. That's not what I wanted. Where's the shape? Is that it? Okay. All right. So I'm going to pick my door. Then they're going to show me, because there's definitely going to be at least one goat left because there's two of them. So then they're going to show me a door, and then I'm going to switch and pick the other door all the time. So it's going to be the last door, the only door left. All right, let's go through this again. So I'm going to pick a door, randomly choose a door. This is all random. Randomly choose a door. The game show host is going to show me another door, and then I'm going to pick the last door, the last door that's left, the last object in our list. All right, cool. Does that make sense? All right, so let's just get after this. So yeah, especially when the math teacher brought this up, I thought it was, well, one, I wanted to do the simulation to test this because she had explained that they had done it in class and proven it. Well, I was like, okay, well, how are you doing that? Because she said that they did it by in recreating. And well, I was like, well, we can do this with a computer and check this any number of times, and it's unbelievable how percent. Well, you'll be able to see, but it just becomes, it's like flipping a coin. The more times you flip it, the closer it gets to 50%, and your significant figures just go out and out and out. It's just I don't know, it's cool. I'm not that good with probabilities, but when it's a concept that I get, I really love it. So all right, so we're gonna pop out a choice. So range 3. So let's go over this, why I'm popping out. I'm removing the first random choice. Pick an index, pop it out. Boom. So now we're down to 2. So it's at least going to have one goat, right? So now I'm going to remove a door. Now I'm going to remove a door that has, we need to look at remove. So we got door, right? I just realized that. All right, so we need to look at pop and remove. I thought we did that, but we did not. Who knows pop and remove? Yeah, I changed. Thank you. I just changed it to door. Thank you. So we put door in memory, and then we need to look at dir on door. So we have pop and remove. I realized we did not do pop, remove. Sorry. Wow. Door. Pop. Okay. It will remove and return item at index, whatever we index, or if we leave it blank, it defaults to -1, or the last object. Remove, well, you'll be surprised. Okay, the very cool thing about pop. Okay, the very cool thing about pop is it brings it out and returns. So you can you do two things at one time. You go and grab it, and then you can assign it to something because it pops and returns it. So if you don't put it with something, assign it to something, it goes away. But right now, we are pulling it out of the list. We're pulling it out of the list. Then we have our 2. Then we're going to have a goat shown, and then we're going to have something left here. And either this is going to be the car or a goat, but we're going to take this one every time. Then now, no, it doesn't put it into memory. It pulls it and as you're pulling it out, you can assign it to something. But if you don't assign it to something, it goes away. So so let's see. Am I not? Because right now my first choice, I just want it gone. What you'll see here in a minute is we'll do remove, and we'll see. So if I wanted to pop it out and then have it assigned to something, because right now we are just because we're switching. So I could have used pop out a random choice, grab it and assign it. I could have done that, but right now I just wanted to pop out and have it go away because I'm not using my first choice. I'm going to go for this one. So I'm picking this, going away, don't care what it is, because I already know I'm going to switch. I'm going to what's left. So I'm grabbing this, throwing it away, going to see a goat, because they're going to show me a goat, and then I'm just going to get the other door. I'm going to pick whatever's left. And if you think about it, 66% of the choices are being removed for me. I'm just going to take the last one. That's why this works. All right. Have I thoroughly confused everybody? So, all right. So now, I took it, pulled it out, got rid of it. Now remove, this is what's very cool. Help on door dot remove. Removes first occurrence of value. So you're actually passing in. So I got door. So I have goat. So if I go door dot remove goat, then I go door. So I have goat and goat. Now we can't see, so it does not remove index. It goes and finds the object that you want to remove and remove it. So when we pick here and then we can, so that now I'm going to be down to 2 objects. Then I'm going to remove a goat because again, doesn't matter because there's at least going to be 1 goat left. There's either going to be after this first choice, I'm going to grab it, throw it away. Doesn't matter because we already know we're switching. All I know is that I'm going to get whatever's left. So either this is going to be a car or a goat, and I'm going to throw it away. And there's always going to be at least 1 goat here, right? So then they're going to show me a goat, and in this scenario, I'm always going to get what's left over. I don't care what's left over. I'm going to take what's left over, and this is how we're going to do it. So second choice equals door 0. Then if second choice equals car, then wins. Else losses equals 1. All right, let me pop over here and see. All right. Well, I thought it was going to remove doors. All right. So as you can see, that is not with remove. Does it have a default? It would only remove first item if that was a default value. Okay, good. Does that make sense? And I misspelled second. Awesome. Thank you. So does that make sense? In the if statement, you would write an error and spell. Awesome. Thank you. No, you guys are great. No, that was actually one of the things. If I haven't said this, one, this has helped me with my typing because I've had to be more consistent. But two, you have to come up here and you have to problem solve. Not only are you problem solving and laying out how to solve the problem, but when you make a mistake like this, you will be sent. You will be sent and be like, look, you're trying real hard. I get it, but I got this and this doesn't make any sense. All right. So cool. So yeah, that only just like this. So yeah, no, whenever you're seeing this and you don't have any equal signs, a default argument, optional argument, default optional, basically same thing. Okay. All right, let's keep on moving, keep on trucking. So actually, we may only get to about 90 minutes today. So now we need to do our for loop with how many times we're going to do this, because we've created our number of times. Then if we're going to change, so then we need to have some logic here to which function to run if change is true or false. Let's get on the right layer. So for I in range x, then let's bring this up. Let's get rid of that. If change, then switch, yuck, and else, no switch. All right, so now we need to lay this out. I'm just going to copy these two, because if I've already been spelling this much. All right. Ooh. Okay. All right. So let's go through this. I think we can see all of this. So I have my change. So I'm bringing this in, then going through. And then down here is I'm testing how many times are we doing this. And if change is false, so right? So this is either going to be true or false. If it's false, we switch. Excuse me, if it's false, we don't switch. See why I set this to default to true? Excuse me, to default to false. So if that's true, we run switch. We run this. We call this function. If we don't switch, if that's false, if they don't input to change, we come up here and run no switch. Very, very standard. All right, so now let's call this and run game 10,000 times. All right. Wins 33% of the time and loses 66% of the time. So print and game 10,000 true. All right. This is where it gets weird. This is where it's so crazy. So if you switch doors, you win 66% of the time and you only lose 33%. It's just absolutely nuts. And I remember when the first time I did this, I was like, there is no way that that's true. And then I went back and I laid out the logic and I was like, this is absolutely the truth, and how just very, very interesting. So actually, you know what? We flew through this. Do we want to look at open and URL lib? Because we can limp through. It's not so complicated, so I can use my old notes. Everybody want to do that? So we can Stay on a little bit longer? How's that sound to everybody? I can go a little bit more. I really thought with all this would last. All right. URL? Okay. So cool. Let's go ahead and do that then. Give me a moment or two to dig up these things, because I know I have it very close. There's the Raven stuff. URL lib. URL. Oh, I'm in the wrong file. URL lib. All right. So here we go. We need to let's comment all this out. Check and see, because again, I lose track if URL lib is already in here. I know what program I can check. Import URL lib. All right, I have one program that's not touched. So we're going to be looking at URL lib. Anybody ever heard of URL lib? URL lib. And then, if we can get through this, and we can do, I don't know, another 15, 20 minutes. That'll get us close to 90 minutes, and then I'll make sure we have 2 hours, because that'd be 2 weeks in a row not doing it 2 hours, so I apologize. All right, URL lib. Let's just look at it. Help URL lib. And this is where it gets odd. Packages. So now we have to be laser focused on what we want to import. And then after this, I know what I forgot to do. We didn't sort the dictionary. That is so cool. So we're going to do that next, because I have a feeling this won't take that long. So URL lib, whenever you have things like this, packages, you then need to be laser focused to bring them in. So then you're going to do request as URL. So now, because I know this can get so confusing, so odd. So now when I run, actually, let's do this real slow. Help URL lib. No, I want to do dir on URL lib. Okay, so see, it only has parse sitting in here. So then when I go and do request, so now I run dir on URL lib. So see, now I have request and response. I know this is weird, but I don't want to do packages yet, but you begin to see that Python helps you manage memory. So it will only bring in things that you say, hey, I really need this. And okay, so request and response. So now we're tipping our toe into client and server. So you're going out, requesting, then you're getting a response. Does that make sense? Let me see. All right. So now I'm sure you've learned by now, and it's dangerous for me anyway to be typing all of those letters. So we're going to shorten this to as URL. And in case we have anybody new joining us, I'm Sam. doing some free code camp streaming. I'm from Python Basics. Every video that I've done here, I have micro videos on my channel. So there's pluses to both of them. A lot right here is a lot more freestyle and a lot of interaction. The other, and also a stream of consciousness, where the other is micro videos, just laser focused, one subject at a time. All right. So URL and its request. So now we're going to have, so now let's look at help on URL. Oops, didn't bring this into memory. Help URL. Holy moly. Let's run dir on URL. See why you don't bring it all in when you import URL lib? It's ginormous. So this is just, we're just going to be touching the tip of the iceberg with, where is it? URL, then URL open. If I knew my alphabet. So see, there we are. And then we're going to bring in the file and then drop it in. And then we need to understand the text, and then we're going to look at open. Then we're going to write, and then we're going to go from there. So let's see how we do. So let's bring this down here. Help URL. All right, we know that's a ton of it. Yep, I want to expand this, and I know it's a lot. Okay, URL lib request, and it's in the URL module, and you have a ton of support. And then here are the classes, and then as you can see, I think there's even more packages. Okay, but we're just going to be touching URL open. Okay. And I think I have this. I know I have I put the Raven on my GitHub, but maybe I'll go at the top of it and put this file so you can practice it. Let's get this back undone. So now let's bring this over here. So you pass in the address, and the reason why I chose the Raven is because it's public domain. It's very, very old. As you'll see, it's 1836, and that's actually 1845. So it is when he died. It's 100 years past after the author's death. So all right. Oh shoot. There we are. So now we bring this in. So we do text equals page. Actually, let's go real slow. Page. No. Aha. So now here's my response object, because it came back. Like I said, you have your URL open, because it's that's going to take forever. Dir on URL. It brought in request and response, right? And now we have a response. So now we need to read it. And we run dir. And look, dir, if I haven't said this in a while, dir and help your friends. Don't try to memorize this stuff, because you will get into, you'll get URL to the Raven is the description of the video. I can't post URL. Can't post URLs, but the video was dictionary part 2. Well, thank you very much for doing that. Okay. Well, I really appreciate that. So everybody, Jan is already on top of it. If you have a hard time coming back and can't find this, it's dictionary part 2. So all right, so cool. All right, so we're running on page. All right, here we go. So now my page object is my response, right? So my page object is a client response. And what can we do with page? Page can read. Okay, so let's read it. So text equals page dot read. All right. So text 70 lines. And what is okay? All right. Super important right there. All right. So help on text. Ooh, it's bytes. What can we do with bytes? Let's see. Ooh. Oh, we can do all kinds of stuff. So there's the help on it. But so we can be laser focused. Dir on text. So we just ran help. Oh, wow. Was that text? Yep. And then here's the breakdown of all the methods. But here's a list of all the methods that we ran. So, okay. So we have, we can do all of this and we get it. But we can clean this up just a little bit. Text equals text dot decode. There we go. It's just a regular text now. So now give me a second because I need to figure out where. All right, 3.8. All right, I don't have this, so we can. All right. So now what we need to do is, now that we've brought this, and we still have. I want you to see this. You want to be a good steward of connections. So right now we have an open response right now. So we need to close this. We need to make sure we close the page. Page.close. You don't want to leave anything open. You want to finish it up. So now page, still a response object, but it's closed. Okay. So now we're going to create a file. File, open. We're just going to name this the Raven. .txt. TXT. Now, all right. Open. All right. Open. File name. File object. Built-in function in module input output. Now, you do not, what I just say, you do not have to remember, because our little shopping list is going to come very handy. So, all right, R, read. What does it default to? Mode, R, defaults to R, defaults to read. W, open for writing, goes to the first. X, creates a new file, open it for writing. A, open writing appending into file if file exists. Binary, text mode. Open a disk file for updating. This is so cool. New line mode. All right. So there is a lot here. We are opening a file to write. All right. And we'll get into more of this. I don't want to do, especially don't want to do it, context editor. We're not going to do a context editor right now because that can really throw people for a loop. We're just going to open the file, write to it, close it. All right, let me get this over here. All right, so right now, here is the last order of my files that I have. So we are open. We have our file around. It's not what I wanted to see. This. Let's bring this in so I can read these. Okay. So all right, we open, close, brought it in. So now we have all of the data that we want and sitting in the text object. So now we're going to create a file object. We're going to open it. What are we going to name it? We're going to call it the Raven.txt. Then we're going to write to it. All right. So now I have a file object. File. Sorry. Okay, I got a file object. What can I do with my file object? All right. I can read lines, seek, mode, all right, and of course it's right on the seam. Or I can write to it. I can read and write. So whenever you're doing something to your file object, it has a method, read, write. So we're going to get our file. We're going to write to it, and we're just going to, what are we passing? What are we passing to it? Our text. Now, we also want to be a very good steward of our connections and what we have to do with things. So we're opening it, we're writing to it. Excuse me. We're opening our file, we're saying we're going to write. We write to it, we close it, and we go from there. All right, so that's that. Whoa, look at this. Handy dandy little thing. We will be, I promise you. Okay, since we're doing this now, let's do our shopping list next week, and you'll see how we handle that. There's a way that you go this, then that, and this. And that's your little tease for this week to come back. So, but no, there is, and actually if you read the documentation, it'll tell you. I'm not going to tell you until next week. So, here's our nice little pretty Raven file. God, look at that. And we're going to we need to look at this text. I want you to look at this format. Just laid out just like this. I want you to look. Does the spaces, has the in, have we talked about this escape character? In? Well, I really appreciate it. It's interesting how I've stumbled and bumbled and stumbled across all of this. I love teaching Python. I'm more of a teacher than I guess I thought I'd ever thought, but I absolutely love. So this is here in all kinds of gobbledygook, but all these nice, awesome little rules sitting right here, and then bam, comes out in this perfect format and tells text exactly what to do. I mean, look at this. It's just right here, and it knows to do a new line and come through and just look at it. New line, whole new line. You can just see it right here. Boom. New line, new line. All right. Now, cannot believe we didn't do it. So we're done with this. That's open. And since we've done these two this week, we'll do our shopping list next week. And I'll try to figure out how to make that sound better than a shopping list, so we get a lot of people who really can understand file control. And then we're going to build a context manager that is it handles a lot of things for you. It's the with keyword. It's phenomenal. Very, very powerful. All right, I just realized we did not sort our book. So we need to look and see how to sort our book that we just did. Our dictionary with our book. So let's do that, and then we'll wrap it up. So, all right. So let's get our book down here. Where did our book go? All right. Copy. We won't go back and forth. Copy and paste, undo this. All right, so then book. 100 and how many keys are there? How are we going to find out keys? So we do book, Lynn, book. 569 different words in the Raven. 569 because there's 569 keys. So that's not the total of Lynn, what do we call it, file. So now we're going to do Lynn on file. So the total poem is 1,059 words, and there's only 569 different words. So we had a lot repeat. So now we're going to see how to handle this. So we need to create a function last, and you'll know why in a second. Return x minus 1, then book. Now we need to turn this in. We need to see all the items. Book.items. All right, so now we need to sort this, and you'll see why we did items here in a second, because we need the key and the value, right? We need to be able to see it. We need to be able to then sort it and then go from there. So now we're going to do sorted book equals sorted. Didn't want to do this with lambda. We could do this with lambda, but I know that can be very tricky. I need to do a bunch of lessons on lambda, because once you get it, you get it. All right, the key. So first it's book. So it's my key and value. Then my key to the sorted is last. I want you to sort it off that, and then we're going to reverse it. So it automatically goes from lowest to highest. I want to see which words in the Raven occurred the most, and then go backwards. So reverse, true. That's horrible. All right. So for I in sorted, sort book, and oh yeah, in this sample, I only want to see the top 10 words in the Raven. That's what I'm doing here. So print I, and 0, and a colon. Guess I didn't feel like putting this in an F-string format. Wonder how old that is. Close that out, close that out. Oops. What'd I miss? I in top 10, 1, 2, print. Ooh. What didn't I close out? Let me see. Where's my syntax error? I got an error somewhere. Alright, we're gonna cheat. Copy this. Paste that. There we go. Wow, looked exactly the same. I wonder what I did. Did anybody catch what I did? Okay. So here we go. So this is the sorted book, sort book. So I sorted it. I took the file. We threw it into. Thank you. Okay. All right. So I throw it into my dictionary. If the word doesn't exist, I count it first time. If it does exist, I increment it by 1. So then I created my last function because I'm sorting this by the last of the key, the value, key value. So I'm sorting it by value. Don't care what, because when you sort a dictionary, you will be sorting by the key. So if I just sorted my dictionary, it would come out in alphabetical order for my keys and not caring what my value was. So I have to resort this off of the key for my items right here. So because I took key and value, brought in items, so book right now is my key and value pair. How many times did those occur? So then I took my key and value, sorted it, went in reverse. So I went in reverse most. So I want you to sort it by the value. And I wanted to go in reverse. I want it to be, it automatically goes from smallest to largest. I want you to go in reverse. I want you to go from largest to smallest. And then right here, I printed out each key and value like so. And I brought it in because my sorted book is this right here in order. And my, here. And, oh shoot. There's a lot in memory. That's why this is acting up. Sorry, guys. So then, the case matters in sorting. Yes. Let me just bring this back in. There we go. And to probably be a little, did you see how slow this was? So it probably wouldn't hurt to do because I saw it in my notes here, and now that makes sense. So now I have a file object and a book object, so it probably wouldn't hurt to stop being a memory hog and start deleting book and file up here, especially file probably. But so here we go. So the top 10 words are the, and, I, my, of, a, that, chamber, this, and at. The or the happened 56 times in the Raven. So there we go, guys. You guys are absolutely awesome. Thanks for coming back and hanging out with me for another week. I want to appreciate Quincy and Bo for allowing me this opportunity to connect with you guys, because if there's anything I can help you guys with and saving you some pain and time and energy in your Python journey, I want to do it, because mine has been a bumpy road, and so that was the reason why I created the channel that I did at Python Basics. Was what would I want if I were starting over? What would I want the channel to look like? And that was how I started. And also did an experiment, put together, if you hadn't seen it, the first 6 of my live streams, it's 5 hours. So now you guys have this everywhere. So you can go back and look at it. It's going to be a little bit different everywhere. Mainly the same big chunk, but a lot of, like I said, a lot of stream of consciousness. So things that It's like when you hear the audiobook, the reader, the author might go off on a tangent and explain what they were thinking, and I've seen that a lot. So you get a little bit more in depth. So don't just do this and think you have it. You've got to practice it. Just like I was talking about at the beginning, 10,000 hours. 10,000 hours. However long it takes. Doesn't matter how long it takes. Just do it. So, all right, guys. I've rambled on enough. Thank you guys for putting up with me and hanging out with me. I really appreciate it. It's very humbling. Right now we got 140-something people here. Like I said, very, very humbling. So as always, guys, thanks for watching. Please hit that subscribe button for Free Code Camp if you haven't already, and also that like button. So I will see you guys next week, and we will work on that shopping list so we can really examine context managers and files. I think that's a great idea. All right, guys. See you guys next week. Bye.